Welcome to part 1 on trigonometric equations. An equation that contains trigonometric functions is called a trigonometric equation. Remember that when we are dealing with equations, we are solving for values of the unknown that make the equation correct. For example, if we had sine squared x plus cosine squared x equals 1, this is an equation, but we also saw that this relationship is an identity. And that means the equation holds for all real numbers. Hence, the solution to this equation is all real numbers. But how about tangent of 2x minus 1 equals 0? That's the goal of this section, to find the values of x, if there are any, in which this equation holds. Keep in mind that since the trigonometric functions are periodic, if we have a solution, we have infinitely many. So we first find the solution in one period and then find all the solutions. In this section, we see how algebra, inverse trig functions, and identities come together in helping us to solve trig equations. Let's learn different methods in the following examples. In the picture, we see that we have a sine of 5 pi over 6 plus 2n pi will equal 1/2. And also that sine of pi over 6 plus 2n pi equals 1/2. So we need to think about what will give us a value or a height of 1/2. And we know that the angle on the unit circle that will give us a height of 1/2 is at pi over 6 and at 5 pi over 6. Those are the two values for which we will get a height of 1/2. Now, remember that we can go around and around and around this unit circle as many times as we want. That's what this n stands for. We can keep going around the circle n times, which means however many. And because of that, we'll go ahead and bump 1/2 as we go around the unit circle in two different places. And you may recall from previous sections where when we look at moving around the unit circle multiple times, we can also think about that with respect to time and the angles. I mean, it just depends how you think about it, and how the sine function can be thought of as unwinding off the unit circle onto the x-axis. And then the height can be these curves for sine. So how high, how low, how high, how low does it go? And then along that higher region, we have places where the horizontal line at y equals 1/2 bumps this sine curve or sine function. What you have to think about is how you'll represent those two values, because if we were looking at cosine, you'd have different repeating points or angles. In this first example, we're basically just asking exactly what we had up here previously. When sine of theta equals 1/2, we can say sine inverse of sine of theta is equal to sine inverse of 1/2. That means theta is equal to the sine inverse of 1/2. And we can find this in our calculator if we haven't memorized it already, but we know this happens at pi over 6 and also at pi minus pi over 6. Do you notice that that will give me a 5 pi over 6 if I take pi and subtract pi over 6 from it? This is because we're looking at a reference angle when we are looking at the height. And so pi over 6 is the reference angle. And the next point at which this happens is at 5 pi over 6. Now that's for one period of sine. So now we have to think about how we could write this for every additional time this happens. Well, pi over 6 happens every one rotation, so we can say pi over 6 plus 2 pi n. And then for 5 pi over 6, that will happen every rotation, full rotation. So we'll say plus 2 pi n. You will also see this written as 2n pi. These are equivalent. You could also say the same here, 2n pi. I've also seen it as 2 pi n. It just kind of depends on what you prefer. Now, for cosine of x equals 0.72, recall that on a unit circle, 0.72 is how far you've gone in the x direction, and so we'll look at our unit circle first, and then we'll look at the repetitions unwound. If you think about this, we will have values in the first and fourth quadrant for x positive. So this value represents x, and x is equal to 0.72. So if I break my circle at x equals 0.72, I need to find, if I'm looking at how far I've gone in the horizontal direction, the distance here from 0 out to the right along the x-axis is going to be 0.72. Because of that, I need to solve for the angle, and so I can say cosine inverse of 0.72 will give me x. And my radian measure, clearly this is going to be a radian. I suppose you could do it in degrees as well, but we're hopefully getting to the point where you're more comfortable with radians than you are with degrees. I'm in radians. I will calculate cosine inverse of 0.72, and I get a value of 0.76699, etc. I'm going to go to 2 decimal places, which will give me x is equal to 0.77. And now I need to figure out if that's the only answer, because remember, I was only given this first radian measure. So I have 0.77 radians to get to 0.72 horizontally. And now I need to figure out if that's the only point. Think about how you would represent the other point down here in radians. I know that the entire distance around the remainder of this unit circle will give me 2 pi radians. So if I want to figure out how to represent the distance just to this other value in the fourth quadrant, I can say 2 pi minus 0.77 radians So 2 pi radians minus 0.77 radians will give me the distance in the fourth quadrant that I must travel around the outside edge of the circle, or an angle, the angle for which I will get 0.72 in the fourth quadrant. So I'll take 2 pi and subtract the previous answer I got, and my other answer is 5.52. Now the last part is to list all the solutions. So we'll go ahead and say plus 2n pi, meaning we could just keep on repeating this rotation, because remember, as we unwind cosine, it continues to go to the left and the right forever. So that's why we say plus 2n pi. And for 5.52, as it continues to unwind along the x-axis for this function, we'll say plus 2n pi for that as well.